This is CodeBattle. I'm Mitch, and along with my colleagues John, Patrick, and Ming, together we created CodeBattle, a way to learn the basics of JavaScript and the fundamentals of programming by completing challenges against other users. So let's hop right into a code battle. First, I'll log in, and then I'll join the quick play queue. In this queue, as soon as I'm matched with another player, we'll hop right into a game. Once in a game, the question is presented on the left. This is a Fibonacci series question, so I'm going to get right into a recursive solution. I'm going to start writing some base cases here, and I'm going to continue on and then do a recursive return, and whoop, looks like my opponent was a little bit quicker than me. But that's fine. I can still finish my answer. I pass all the test cases, and then I'm presented with the I lost, but at least I tried page. I can see my answers on the left and my opponent's answers on the right. So even though I lost this code battle, I can see that my opponent's answers were a little bit cleaner than mine. And so I can learn from that and take that knowledge with me to the next code battle. With that, I'd like to hand it off to my colleague, John.
Thank you, Mitch. We just showed you a demonstration of a game using quick play. Now we'd like to show you a game using private lobbies. To do so, you go up top, click Create Lobby, which will generate a unique link for you to send to a friend. The battle won't begin until both people have joined the room. When a user submits the correct answer, both players will receive drop-down notifications along with live progress bar updates. We also included power-ups. This gives a player the chance to send the attack over to their opponent to slow down their progress. The game is over when a user answers all of the questions, and I'll pass the mic over to Patrick now.
Thanks, John. For our tech stack, we chose to go with the NERP stack, which consists of Node, Postgres, Express, and React-Redux. Since our site required real-time updates, we used Socket.io, which allowed us to connect users together by implementing game rooms and lobbies. We also implemented a large portion of our game logic using Socket.io. As you may have noticed, the last user submitted an answer using ES6. When user submits their code, we use Babel to transpile it to ES5, which then gets executed on a Node instance on a Docker container. Since it would be extremely irresponsible of us to run user-submitted code directly on our server, we chose to use Docker to create small isolated instances of Node environments that will allow us to run the code safely and in an isolated environment. I'll pass it on to Ming, who will talk about testing.
Thank you, Patrick. So we use Mocha and Chai for search and testing of user-submitted code for correctness and validity. We also use Enzyme for front-end testing, as well as Redux to keep track of global state. Let me give you a brief rundown of how some of that works. So to get the user from the server, the store would do a GET request to the server, which checks rec.user, which sends it back as a user object back to a store. And then back on the front end, the app checks the store to see if a user is logged in or not. Depending on that, it will render views differently. So for example, account button or login form, personal versus global match history, or a create lobby link versus please log in message. Match results works similarly. So on a correct answer, code editor will do a dispatch and emit. So on the dispatch, the store will update the user's own answers array. And on emit, it will emit to the opponent's client, which will then, whose socket.on will do a dispatch to their own store and updates the user's opponent's answers array. And that was just a brief rundown of how our app works. Come battle live and hone your skills at codebattle.win. Thank you.